All right, today we're going to put ourselves in a high-pressure situation, the coding interview. We're going to tackle a pretty common programming challenge, not just to get the right answer, but to really get into the mindset that separates a good developer from a truly great one.
So what is it? What's that secret ingredient? What makes one developer's solution just pop, while another one just falls flat? It's a question that really lies at the heart of every single technical interview.
And honestly, the secret is usually right here. A great programmer, they don't just hand over code that works. They write code they can explain, they can justify, and they can prove is rock solid. They can stand by every single line and tell you why it's there. Let's see exactly how that plays out.
So, here's our challenge for today, and it's a total classic. We're building a rewards point calculator for a retail company's loyalty program. Now, it seems simple enough on the surface, but trust me, it's packed with little traps and details that really show you how a developer's mind works.
Okay, so here are the rules we're getting from the marketing department. For any purchase up to $50, you get 0 points. Simple. Between $50 and $100, you get 1 point for every single dollar over that $50 mark. And for anything over $100, you get a flat 50 points for that middle range, plus 2 points for every dollar over 100. Sounds pretty straightforward, right? Well, the devil's in the details.
Okay, first things first. We have to translate these business rules into cold, hard logic. And the best way to do that to make sure we've got it right is to walk through a real example. So let's just grab a number to work with. How about a $120 purchase? How are we going to break this down using our new rules?
Okay, so first up, we've got that chunk of money between $50 and $100. Our purchase of $120 completely fills that $50 wide bucket, right? So that's $50 at 1 point per dollar. That gives us 50 points. Easy.
All right, now for the rest. What's left over $100? $20. And the rule for that tier is 2 points per dollar. So 20 times 2, that's another 40 points.
And now the easy part. We just add them up. 50 points from the first tier, 40 from the second, boom, 90 total points. See how those tiers stack on top of each other? That is the core logic.
Okay, so now let's turn that thinking into some pseudocode. This function maps directly to the rules we just went through. But look at that little note at the bottom. That's the important part. It says we're only using whole dollars. This is a classic interview gotcha. A great developer asks about stuff like this upfront to make sure there are no surprises with cents messing up the calculation.
So that function is great for one purchase. But in the real world, you're not dealing with one. You're dealing with millions. So how does our little function fit into the big picture, into a larger system? Let's check out the data pipeline.
It all starts with just grabbing the raw transaction data, who bought what, when, and for how much. Then, for every single one of those, we run our handy calc points function. Now here's the crucial step. We group all those points by the customer and by the month. This is what lets the business do things like send out monthly statements. And finally, you just sum it all up to get those nice, clean monthly and grand totals for everyone.
Now this is where you really start to sound like a senior developer. You talk about efficiency. You'd explain that the time complexity is O of n, which is just a fancy way of saying if you double the transactions, it takes about double the time. It's efficient. And the space complexity, or memory, depends on the number of unique customers and months of data. Thinking about this stuff shows you're not just a coder, you're an architect who plans for scale.
All right, now for the part that really separates the pros from the rookies. Thinking about what could go wrong. A great developer is almost paranoid about edge cases, all the weird, unexpected inputs that could totally break the whole system. Remember that whole dollar rule we talked about? This is exactly why it matters so much. A purchase for $100.99 should still only get you 50 points. That 99 cents? It doesn't count. It doesn't push you into that next 2-point tier. Nailing tiny details like this is exactly what interviewers are looking for. So, how do you prove your code is rock solid? You test it. And not just with easy numbers. You have to hit all the boundaries, just below 50, right on 50, just above 100. But a pro doesn't stop there. What about refunds, which are negative numbers? What about transactions where the data is missing or just plain wrong? You need a plan for all of it.
And here's a pro tip for how you talk about testing in an interview. You use industry lingo like arrange, act, assert. It's a super simple but powerful pattern. You set everything up, that's the arrange. You run your code, that's the act. And then you check if you got the right answer. That's the assert. It tells the interviewer that you're not just testing, you're thinking about how to write clean, effective, and maintainable tests. Okay, so our code works for today. It's solid.
It's tested. But what about tomorrow? What happens in 6 months when the business wants to change the rules, or when your user base suddenly doubles? A top-tier developer is already thinking about that.
So how do you make it future-proof? Here are 3 big ideas. First, get those numbers like 50 and 100 out of the code. Put them in a config file so marketing can change the tiers without needing a developer. Second, think bigger than one country. Plan for multiple currencies right from the start. And finally, if you need to handle massive scale, you could use something like stream processing instead of trying to load everything into memory. This kind of forward thinking is what turns a good solution into a great one.
So you've done it. You've built this incredible solution. It's logical, it's efficient, it's totally robust, and it's ready for the future. But it's not over. There's one last test. And honestly, it might be the toughest one of all. Can you clearly explain what you did and why you did it?
Just picture it. You're in the interview. You've just presented your flawless code, and the interviewer leans in and asks this very modern, very direct question. How you answer this single question says everything about your confidence and your ownership of the work.
The perfect answer here is honest but confident. You don't deny it, you own it. You say something like, yeah, I absolutely used AI tools to brainstorm and check my syntax. But the core logic, the edge cases, and the test plan, that was all me. I had to validate everything myself to make sure it actually met the business requirements. See? That shows you're resourceful, but that you're still the one in the driver's seat.
And that really brings it all home, doesn't it? We've seen that writing that one little function was, the easy part. The real challenge, the real skill, is in seeing around corners, planning for the future, and being able to clearly articulate every single choice you made. That's how you think like a programmer. All right, let's get into it. Have you ever stopped to wonder what kind of complex machinery is actually humming away behind those super slick, fast apps you use every single day? Well, today, we're going to peel back the layers. We're deconstructing the modern tech stack from a senior engineer's point of view.
You know the feeling. You tap a button and the screen just updates. Instantly. It feels like magic, doesn't it? But it's not magic. It's just really, really good engineering. So the big question we're tackling is this. What is that invisible architecture, that hidden scaffolding, that makes the whole experience so seamless? We're going to take a journey behind the screen.
So our journey starts right where every user's does, the front end. This is the user-facing layer, the part of the app that you can actually see, touch, and interact with. But trust me, it's just the tip of the iceberg. At the very heart of this layer, you'll almost always find a powerful framework, like Angular. Its entire job is to build that user interface, the UI. Think of Angular as the director of a Broadway show. It's controlling everything you see, how the actors, or buttons, react when you interact with them, and how all the data is displayed on stage. It's all about making sure the performance is smooth and totally responsive. And the power of a modern UI is honestly staggering. We're talking about the ability to handle over 10,000 real-time events. Things like status updates, new messages, you name it, all without a single stutter or freeze. Now that is the kind of invisible engineering that separates a truly great app from a frustrating one. Okay, so your click on the screen needs to talk to the brains of the operation, right? But here's the thing, it doesn't go there directly. First, it has to pass through this critical middle layer. I like to call it the smart gateway, which is absolutely essential for the system's resilience and speed.
And for this super important role, engineers turn to technologies like Node.js with the Express framework. This is our middleware. It acts as this really clever and efficient go-between, sitting right between the user interface you see and all the heavy-duty processing that's about to happen in the back end.
So what does this gateway actually do? Well, it is a master multitasker. First, it acts as a security guard, checking your digital ID, what's called a JWT or JSON Web Token, to make sure you're allowed in. It's also a speed booster, storing or caching frequently used data, so it doesn't have to bother the backend every single time. And finally, it's a translator, taking messy, complex data and simplifying it into a clean, easy-to-use format for the UI. In short, this one layer makes the entire system more secure, way faster, and a whole lot more efficient.
All right, our request has been verified, it's been optimized. Now it's time to enter the real core of our system, the back-end engine room. This is where all the complex logic and the serious heavy lifting of data processing actually happens.
Now, to understand modern backends, we really need to talk about architecture. See, in the past, a lot of systems were what's called a monolith, one gigantic, tangled-up codebase. If you wanted to make one tiny change, you had to redeploy the whole thing. The modern approach? Microservices. This means breaking the application into lots of small, independent services that can be updated separately. It just makes the whole system way more flexible and a lot more resilient.
Here's a great way to think about it. Imagine a restaurant kitchen. A monolith is like one single chef trying to cook a huge 3-course meal all by themselves. If they mess up one little thing, the whole meal is at risk. It's slow, it's risky. But microservices, that's like a full kitchen staff. You've got specialists for appetizers, for the main course, for desserts. They all work in parallel, they're much faster, and hey, if one station has a problem, the rest of the kitchen just keeps on cooking.
And in our microservices kitchen, we've got some serious powerhouse tools. Those specialist chefs, they're often built using a language like Scala, which is just fantastic for handling complex logic and crunching massive amounts of data. And to get the ingredients, the data, between all these chefs, quickly and reliably, we use something called Kafka. Just think of it like a super fast conveyor belt, streaming information between all the different microservices.
Okay, so we've seen all the individual layers, right? We have the front end, the middleware gateway, and that back-end engine room. So now, let's put it all together and trace the full journey of one single request from the very beginning to the very end.
Okay, so let's follow a single click. Ready? 1. You interact with the Angular UI. 2. Your request instantly hits that Node.js gateway for a security check. 3. It needs fresh data, so it gets zipped through the Kafka conveyor belt to a very specific Scala microservice. 4. That service does its complex work and sends back a response. And 5. The gateway intercepts that response, tidies it all up, and delivers a perfect piece of data right back to your screen. And this all happens in the blink of an eye.
And this quote from the source material just perfectly sums up why this architecture is so effective. Each part has a very specialized job. Scala is laser-focused on the heavy-duty computation, while Node.js is an expert at managing all that web traffic and just keeping the user's experience incredibly snappy and responsive. It's really the best of both worlds.
So does all this architectural elegance actually pay off?
Oh yeah, absolutely. In one case, this exact design led to a 30% reduction in load time. Now that is a difference you can actually feel, turning what could be a frustrating wait into a seamless experience.
Okay, so we've seen all the intricate layers of the machine. But what about the mechanic, the person building and maintaining all this? Well, in a system this complex, the role of a senior engineer goes way, way beyond just writing code.
You see, a senior engineer's real value lies in 3 key areas: leadership, a deep sense of ownership, and a relentless focus on the long-term health of the entire system. They're not just building one feature, they are building a foundation that will last.
And that means they're not just sitting there coding all day, they're shaping the entire process. They drive those big architectural decisions, they own the automated deployment pipelines, often called CI/CD, and they mentor junior engineers, lifting up the entire team. And critically, they're always working to reduce what we call technical debt, all those messy shortcuts that can slow down progress later, to make sure the system can grow and evolve for years to come.
And here is the real-world impact of that ownership. By taking charge of the deployment process, one senior engineer was able to improve deployment speed by 40%. That means new features and critical fixes get to users faster and more reliably, which is just a massive win for everyone.
So we end with this question, because it really gets to the heart of the mindset. What is the ultimate goal? Is it just about shipping the next feature as fast as you possibly can? Or is it about building a healthy, scalable, and maintainable system that is capable of delivering features reliably for years and years to come? That strategic, long-term thinking, that is the true mark of a senior engineer.